Hi, I'm Mrs. Hilton, and for today's math lesson, we're going to be talking about the Pythagorean Theorem. We're going to be applying it to some real-world examples and practicing how to solve those. So you're going to need a piece of paper, something to write with, and probably a calculator. Let's go ahead and get started. Okay, so in today's lesson, we're going to work on how to apply the Pythagorean Theorem. We're going to see it in lots of different examples. Let's go ahead and begin. After today's lesson, you should be able to say, I can apply the Pythagorean Theorem to calculate various dimensions in real-world problems. In today's lesson, we're going to cover three different things. The first one is going to be, what is the Pythagorean Theorem? Where did it come from and why is it used? The second thing we're going to cover is its real-world context. We'll work some realistic examples. And then third, we're going to talk about the Pythagorean Theorem in different dimensions. This theorem can be used in 2- and 3-dimensional ways, so we'll practice some of those. Some of the vocabulary that we're going to use are the leg of a triangle, which is either of the two shorter sides of a right triangle. These two sides together form the right angle in a right triangle. A hypotenuse, which is the side of a right triangle that is directly across from the right angle. A right triangle is a triangle with one right angle. And then last, the Pythagorean theorem, a theorem that states that in a right triangle, the square of the length of the hypotenuse equals the sum of the squares of the lengths of the legs. We often see this written as a squared plus b squared equals c squared. If you look in the diagram below, you can see what each of these letters is referring to. So A and B are both different legs on a right angle triangle, and then C represents the hypotenuse. As we practice with this equation in different diagrams, it should become easier for you to see and understand what each of these things represents. The Pythagorean theorem has several real-life applications. This is due to the fact that so many problems can be modeled or represented by a right triangle. If this is the case, then values can be assigned to the sides of the triangle, and the unknown value can be figured by solving for the missing side of the triangle. Where did the Pythagorean theorem come from? The Pythagorean theorem gets its name from the ancient Greek mathematician named Pythagoras. He is thought to be the first person to offer proof of the theorem, but people had noticed the relationship between the sides of a right triangle long before. He studied with Egyptian men known as rope stretchers who helped to build the pyramids. They used a series of ropes tied with knots at specific intervals to lay the foundations of the pyramids accurately. Builders today continue to use the Pythagorean theorem to help when they are trying to make square walls and things like that. What do we use it for? The Pythagorean theorem is an important part in many mathematical fields. It helps to connect algebra to geometry and is also the basis of trigonometry. A lot of the language and things that we'll use today you'll continue to hear as you study math. Not only can the Pythagorean theorem help you find the third side length to a right triangle, but it can also help you find the missing side lengths to squares and rectangles when the triangles are pushed together. We'll practice looking for different instances of this in our examples today so that you can learn how to see these triangles when you're trying to solve problems. The Pythagorean theorem can be used to build staircases, roofs, and even be used to calculate the angle for safely placing a ladder when you need to work in high areas. It's one of the most popular mathematical rules out there because it comes in handy anytime you need to create a 90-degree angle. Let's practice using the Pythagorean theorem in some real-world context. First, let's try using a rope equation like the Egyptians that we talked about before. First, we're going to look at this diagram. Here we see a triangle with different dots. So when the Egyptians used rope to make right angle triangles, they used rope that had been marked out in equal lengths or units. So we can see each of these units on this triangle. Can we use the Pythagorean theorem to determine if this triangle has a right angle? If we just set this up, would we be able to tell if it was a right angle or not? If we count the number of knots on each side, we get the ratio of 6, 8, and 10. So we can see on the leg that's clear to the left, there are 6 dots. We can see the leg that goes horizontally has 8 dots, and then the hypotenuse has 10 dots. Substituting the values into the Pythagorean theorem, we get 6 squared plus 8 squared equals 10 squared. So we can work this out. 6 times 6 is 36, 8 times 8 is 64, and 10 times 10 is 100. So when we add 36 to 64, we get 100 on both sides of our equation, which shows that yes, this is a right angle triangle. So this is one of the applications of the Pythagorean theorem, is to determine whether or not a triangle has a right angle. And we can see in this case that it does. Let's try another real life example. An empty lot is 120 feet by 50 feet. How many feet would you save walking diagonally across the lot instead of walking the length and the width? The first thing we can do for this equation is we can draw a picture to help us see what we're talking about. So if we have an empty lot, it's a rectangle. The long side is 120 feet and the short side is 50 feet. So if we wanted to walk diagonally across it instead of walking around the edges, how many feet would we be walking is what we're looking for. The diagonal line will be the hypotenuse, so it will be our unknown value, or C. The A and B values will be the legs of the triangle, so they're 120 feet and 50 feet. We can plug this all into our equation, and we can see that we have C squared equals 120 squared plus 50 squared. As we work that, we can see that C squared will then equal 14,400 feet plus 2,500 feet. So we can add those two numbers together. And then we have C squared equals 16,900 feet. Now, in order to solve for just C, we're going to need to put the square root symbol on both sides of the equation so that we can get to just C, and then we'll solve for the square root of 16,900. Which is actually 130. So C equals 130 feet. So we know that by walking diagonally across this lot, we would have only walked 130 feet. Now the question that it asks is how many feet would we save walking diagonally across the lot? So the next thing that we need to do is to go ahead and add up the length of the legs. So 120 feet plus 50 feet tells us that if we had walked the edges of the lot, we would have walked 170 feet. So then we can subtract our 130 feet hypotenuse instead and see that we would have only walked 40 feet less if we walked the hypotenuse instead of the edges of the triangle. You save 40 feet walking the diagonal. Now, will this, does the Pythagorean theorem still work if we need to know if we know the hypotenuse in one side? Can we use it to solve for a missing leg? Let's try that and see. Suppose that the hypotenuse of a right triangle is 26 inches and one leg is 10 inches. Find the measure of the other leg. So again, to start with, let's draw a diagram so we can see what we're looking at. So we know the hypotenuse is 26 inches, so we can see that clearly marked on this triangle. And that one of the legs is 10 inches long and the other leg is going to be marked with the letter B because it's our unknown. So if we're going to fill this information into the Pythagorean theorem, we can substitute the value of the leg and hypotenuse into the Pythagorean theorem and solve for the missing leg. If you want to pause the video and try to do that here, you can. And we'll work through it together when you're done. So we can see that we have 10 squared plus b squared equals 26 squared. If we square those numbers, we end up with 100 plus b squared equals 676. So the next step is going to be to isolate the b on one side of the equation. We'll do that by subtracting 100 from both sides, which leaves us with b squared equals 576. So the next step in this equation is going to be to find the square root. So the square root of b squared will give us b, and then the square root of 576 is going to be 24, which tells us that this other leg of the triangle, b, is equal to 24 inches. So now we can see that we have all three values in our triangle. One leg is 10 inches, one leg is 24 inches, and the hypotenuse is 26 inches. So far we've used the Pythagorean theorem to determine if a triangle is a right angle. We've used it to solve for the missing hypotenuse, and we've used it to solve for one of the missing legs. Let's try this in an example that of a problem that you might run into. You go shopping for a TV. You want to buy the biggest TV you can that will fit on your dresser at home. Your dresser is 48 inches across and has a shelf 30 inches above it. Remember, TVs are measured diagonally. So to begin with, we're going to draw a diagram just like we have in our other examples. Here we can see that the dresser is 48 inches across, and then we can see that the distance of 30 inches between the dresser and the shelf. So the rectangle here in the middle is going to represent the television, and we're going to remember that it's going to be measured diagonally. So we know the biggest it can be along one leg is 48 inches, and then along the other edge, the biggest it can be is 30 inches. So we need to determine how big of a TV we can buy. Will it be a 50-inch, a 55-inch, or 60-inch TV? Those are going to be our only three choices. So we can start by substituting our information into the Pythagorean theorem. C squared, which is going to be our hypotenuse because TVs are measured diagonally, okay, equals 48 inches squared plus 30 inches squared, because those are the max dimensions that our legs of our triangle can be. So we're going to end up with C squared equals 2,304 plus 900, because that's 48 times 48 and then 30 times 30. C squared equals 3,204. We're going to use the square root on both sides so we can figure out what the equivalent of C is. That's going to give us 56.6 inches, okay? So if we're looking at our question of how big of a TV can you buy, if it needs to fit on this dresser and can only be 30 inches tall, the biggest TV you can buy that will fit is a 55-inch TV that's going to fit in that space. So do you see how we can use the Pythagorean theorem to solve a problem that we might have as we're shopping for a television? Even though it's a rectangular shape, we can find that triangle and apply this solution. Now, we've talked about using the Pythagorean theorem in two-dimensional shapes, like triangles and squares or rectangles. But did you know that it can also be used to find missing values in three-dimensional shapes too? Three-dimensional shapes are cubes, pyramids, and rectangular prisms. So let's work on ahead here and see, work out a 3D example together. So we're going to ask the question, does this theorem work in three-dimensional shapes? So here, if we look at this, we can see that we have a rectangular prism. Let's say we want to figure out the distance from the bottommost left front corner, so that would be this corner right over here, right in front, to the topmost right back corner. So we're going to follow this dotted line here and go to the back corner of this prism. Now, we'll call that value in here. So if we're going to try to solve for this, this line that's marked in, is there a way that we can do that? Can we find a triangle in this prism that can help us solve for that? Let's go ahead and look and see what we can see. So if we look at the bottom, at the triangle in the bottom here, we can look at the bottom rectangle of this prism. We can draw a line from this corner here at the very front to this corner here in the back. We'll call this pink line C. We can see that we have a triangle here whose sides are C, X, and Y. Okay, so using the values that were given, can we write an equation that will help us solve for the length of C? So we know using the Pythagorean theorem, C would be our hypotenuse. So we can say C squared is equal to X squared plus Y squared, because those are our two legs. Okay, if we want a value for C alone, we can use the square root symbol to take the square root of C squared, which would be C, and then the square root of X squared plus Y squared. We can now say that the dashed line, this pink line here, C, is equal to the square root of X squared plus Y squared. Let's continue with looking at this equation now. Now we can see our triangle here. We're trying to solve for the value of n is going to be the hypotenuse in this triangle. Now C is one of the legs of this triangle and Z is the other leg. So we can see clearly here that this is the triangle that we're trying to solve for now if we want to solve for the length of n. Now that we know that the dashed line C equals the square root of x squared plus y squared, how can we finish an equation to solve for the triangle CZN? So we know that we can put c squared plus z squared equals n squared because that's our Pythagorean theorem there. Now we also know that c squared is equal to the values x squared plus y squared. So we can substitute that into our equation also, which gives us x squared plus y squared plus z squared equals n squared. And then we can take the square root on both sides to equal our value of n. So at this point, we can say that n is equal to the square root of x squared plus y squared plus z squared. Now, if we add some values in for x, y, and z, we can solve for the actual numerical length of that line n. Let's try it and see if that makes it a little bit easier for you to understand. So if we have the front of our rectangular prism measuring at 10 units, and the side measuring y at 5 units, and then z being 3 units tall, we can substitute those into our equation. So we know our Pythagorean theorem for this triangle that we're trying to solve for n is c squared plus z squared equals n squared. We know that c is equal to x squared plus y squared. And then we're also going to add z squared because that's our other leg. So we can substitute in our values there. So we have 10 squared plus 5 squared plus 3 squared equals n squared. Working that out, we get 100 plus 25 plus 9 equals n squared. So we can total those up to get 134. Okay, and we want to solve for n alone, so we're going to do the square root on both sides, which is going to give us n is equal to 11.6 if we enter that into our calculator. So we can see here that we've worked through this equation 2 different times using the Pythagorean theorem in order to isolate a triangle that helps us solve for what this dashed line is here for n. Okay, this is a little bit harder problem, might be a little bit harder for you to see, but these are the kind of things that you can solve once you understand how the Pythagorean theorem works. So let's review some of the things we learned today. The Pythagorean theorem plays an important part in many mathematical fields. It uses exponents and square roots. It has applications in algebra, geometry, and trigonometry. So you'll continue to get more familiar with the language that we use when we're using the Pythagorean theorem as you continue to study math. The Pythagorean theorem can help you find the missing side links to squares, rectangles, and triangles. It has many real-life applications, especially if you can work to see those triangles in different shapes. You can use that information to solve different problems. The Pythagorean theorem can be used in building and in planning. It can be used to calculate the angles for safety, such as where to place a ladder when you need to work in high areas. We also learned that it can be used both 2- and 3-dimensionally. Thanks for sticking with the lesson today. I hope you were able to work through some of the problems, but remember that if you need help or you want more practice, you can check the learning guide for more activities. Thank you.